Alright guys, so today you're going to work on a birthday polynomial project. You're going to use your birth date, and this is a video of how to complete it by using my birthday. So you're going to do exactly everything I'm going to do with my birth date, except you're going to use your own birth date. Okay, so this one gives you an example, and I'll post this PDF up on Canvas. But see, April 2nd's right here. So April 2nd, you can either do 2 or you can do 0 2. So it shows you here's 4 2 1976, or here's 4 0 2 1976. You can choose. Now if your birthday is in year 2000, I'm going to show you what to do, because you don't want to end your constant on a 0. We're going to have a different number for your constant term. Okay. Alright, so let's go do mine. Alright, so my birthday is December 3rd, 1985. Okay, so I have the same thing, whereas I have a single term for my day. I'm going to want you to put the 0 there. Okay, so in numerical, my birthday looks like this: 12/03/1985. So you know this is going to be a placeholder. Right, but you got to see how many terms you're going to have. So you start with a constant term, which is 0, and then 1, 2, 3, 5, 6, 7. So you're counting up backwards. So that means you're going to, my exponent is going to be a degree of 7. So it's a 1, so it's 1x to the 7th. Now you're going to play with your pluses and your minuses once we get to Desmos. So right now I'm just going to write something down. And then plus, that's to the 6th power, 2x to the 6th. I'm going to skip the 5th power because that's a placeholder because of the 0. And then I'm going to do minus 3x to the 4th minus x cubed, because there's a 1. You can write the 1 if you want to. Plus 9x squared. I'm here now. And then 8x. I'm going to do a minus 8x. And then a plus 5 is my constant term. So that's the basic template of my polynomial I'm going to graph in Desmos. Okay, but if you were born in the year 2000, so say my birthday was 12/03 year 2000. Okay, I'm going to count down again: 0 1 2 3 4 6 7. We'll count up. So 7. My highest exponent is 7, but I don't want to end my constant on a 0. So you can change this last number to whatever number you want to, but keep in mind it's 1 through 9, no double digits. So you can change it to 12/03/2008 if you wanted to. Okay, but don't have a constant as a 0. Have a number for a constant. Okay. All right. So we go back to the PDF. Okay. Whoops. We go back to the PDF. You're going to use Desmos to do all this, and what I want you to find on Desmos is your roots, your y-intercept, your maxes and your mins, your relative max and your mins, so all of them. Okay, you're going to do a slide on your end behavior. I'll pull up the end behavior chart to show you, and then you're going to make a table of values. Okay, and if you scroll again, this is what I'm going to be looking for right here. Okay, my statement is my birthday is December 3rd, 1985, and then you'll write the polynomial we just formed. Okay, so this will be one slide right here. Okay, and then you'll have a picture, and you can be creative how you want to. You get a chart with 10 points. Okay, all your roots. That means your x, your x-intercept, and your y-intercept. Okay, well, that's right here too. All right, that can be one page, and then your relative maxes and mins. You'll find that with Desmos with the gray dots. And then I'm going to tell you about the sentence of describing the end behavior. You're going to do something with how your leading coefficient was positive or negative, and then how your degree was either even or odd. Okay. All right. So we are going to go to Desmos now. Let's pull Desmos up. It was already there. All right, here we go. So I've got to analyze this. So I'm going to type in what we had. Now again, in the beginning you're going to be playing around with stuff to get the polynomial you want. All right. So what I initially had was x to the 7th plus 2x to the 6th minus 3x to the 4th minus x cubed plus 9x squared minus 8x plus 5. All right, so I'm going to look at this. It really doesn't matter what you do or which one you like, but it's just about changing your positives and your negatives. So say I change this one to a negative. See how it changes the graph? I actually like this one better, so I'm going to keep it like this, but you could change them. So if I change this to a positive, see how it changes the graph more? I'm going to change it back to a negative, but play around and get a good polynomial that's easy to analyze, okay? So, all right, so the first thing it wanted was the roots. So remember your gray dots, your roots are where you crosses the x-intercept. Now these are going to be nasty roots. They're not going to be your pretty factored roots, which is completely okay. All right, so I'm going to get my roots. So I have, first one is, so you would write these down. Okay, so those are your roots. Your y-intercept is where it crosses the y-axis. Okay, so here's the other gray dot. That is my y-intercept right there. All right, so I'd write that down. My maxes and my mins. I'm going to have to zoom out. Okay, but I only have one max and I have one min. I'd write that down. Okay. And then I want you to get a t-table. So to get points, you're just going to take your mouse and you're just going to scroll up and down, okay? See if you can find some good points, like right here. Looks good. But if you don't, I'm okay with decimals, but get 10 points, okay? Make a side of a table with 10 points, okay? Get them scattered around. Don't get the same ones, okay? And then we're going to talk about end behavior, okay? So your end behavior, remember we went over end behavior? I don't know, I keep leaving the screen. So end behavior, I'm just going to Google a chart real fast. This is what you would Google if you need to see it, okay? Just Google end behavior polynomial functions. There'll be plenty of charts that pop up, okay? You can go to images. Don't even have to look at the websites. Here's a good one. All right, so end behavior is right here. Now, if you look at my polynomial, it is over here. See me moving over here? It's over here going down. So it's in the bottom left, and then it ends in the top right. So I want to find one that does the same thing. And if you look, that's going to be your top right box, the odd power with a positive constant, which if you look at the polynomial we created, that is what I have, okay? I have, go to a different color. I have a odd degree and a positive leading coefficient. So that makes my end behavior correct. So my slide, it wanted you to explain, right? So you would say that your end, so if we go back, you would write down your end behavior, which is right there as x goes to negative infinity, y goes to positive, or as x goes to negative infinity, y goes to negative infinity. I think this is wrong. Yeah, they got it backwards. So we'll go to a different chart. How about I just post a chart for you guys, because I did not know they would have a bad one up here. I've used this one before. So I'm right here. As x goes to negative infinity, y goes to positive infinity. See how that's different? This is correct. I'll post this one. X goes to positive infinity, y also goes to positive infinity. Okay? So we would write down on a slide about your end behavior. So this is your end behavior slide, okay? end behavior slide, okay, you would say as x approaches, if your polynomial is an odd positive, as x goes to negative infinity, then f of x goes to negative infinity. And then as x goes to positive infinity, f of x also goes to positive infinity. And then it wanted you to explain that. Well, if you explain that, we looked at the graph. Okay, that's what our graph was doing. And then the chart says that's because my function is a positive odd function. Okay, and you would just say my function is odd positive. Okay. All right. And that's really all you have to do. So if we go back to the polynomial project PDF, we did our checklist. This is our statement. I went over that. T-chart. Seriously, that's just an X, Y chart, and you just get 10 points. Okay, just clicking on the Desmos graph, all right? Or if you want to type it into an online calculator, you can do that. I showed you how to get your roots. That's where it crosses the x-axis, okay? And it's those gray dots. You can have, so if you looked at mine, which is a good time to talk about this, I have 3 roots right here, but I have a degree of 7, so that means I have 4 imaginary numbers, which we went over the conjugate theorem that states you have to have an even amount of imaginary numbers because you have the positive and the negative of each. So I have 3 reals, all right, and that means I have 4 imaginary. So if you want a little extra credit, put in there how many imaginary numbers you have, and all you do is you take how many times it crosses the x-axis, subtract that from your degree, so 7 minus 3, and that gives me my 4 imaginary, okay? So we did that. Y-intercept, that's where it crosses the y-axis. Relative max and min, those are your humps, your turning points. And then we talked about describing the end behavior, okay? And it occurred because my function was positive odd. All right, so good luck. I hope this is a good break from doing videos and study islands and all that stuff. But let me know if you have any questions on this, and I will be glad to help you. All right, guys.